Welcome back. In the previous class, we have discussed about errors and method of calculating errors. Today we will be discussing about significant figures. Now, significant figures, we are talking about numbers and digits. So, I'll give you an example. When we do some calculation, suppose we use a device to measure that device. Suppose we have vernier caliper. I'll show you what is vernier caliper when you come to the school. If you have, we take a vernier caliper and we measure the length of a device. Okay, we measure the length. So the length comes out to be 2.58 centimeter. Now the length is 2.58 centimeter. Now over here, what we can see is 2.5 is an accurate calculation. This 8 is quite doubtful. This 8 might not be exactly. Might not be exactly 2.58, but this can be somewhat between 2.57 and 2.59, not 2.58. So it can be in between this range. So from here, what we can see is 2.5 is the absolute answer, but 8 is quite doubtful. So now this figure is known as significant figure. It means that some accurate measurement plus one digit, one number which is quite doubtful, combines and it makes the significant figure. Now suppose we do another calculation using a screw gauge. Screw gauge is more accurate in calculating the length compared to vernier caliper. Suppose we use a screw gauge and the same thing comes out to be 2.580. Now over here what we can see is 2.58 is not doubtful, it's accurate. Okay, it's accurate length. This 0 is quite doubtful. It might not be 0, it might be 1 or 2 or 3. It can be changed if we take many readings. So this is doubtful. So over here there are 4 significant figures. Okay, there are 4 significant figures. Over here for the same length we have 3 significant figures. I hope it is clear. The digit measures accurately. Okay, the digit which are accurate with one doubtful number is the combination, and that combination is known as significant figures. Now we will discuss the rule of determining a significant figure. There are many rules and it might be confusing, so please note it down, the rules. Okay, the first rule of determining significant figure, that means all numbers cannot be a significant figure. There are rules to determine if it is a significant figure or not. Number 1, the first rule for determining significant figure is all non-zero digits are significant. Decimal point does not affect the number of significance. That is, all non-zero digits are significant. It means that suppose the number is 2.368, suppose another number is 2368. These are non-zero numbers. That means 0 is not included in the number. Despite of point wherever it is placed, this number, there will be 4 significant figures over here. Over here also there will be 4 significant figures. If the point is kept like this, then still there will be 4 significant figures. So without a 0, if the 0 is not included in the number, then there will be, the total numbers will be the significant figures. Okay, that means non-zero numbers are significant figures. Doesn't matter where the point is being placed. That is the first rule. Now the second one is all zeros between 2 non-zero digits are significant. That means if zeros are there in the number, but if it is there between 2 non-zero number, that will be a significant figure. Suppose example is 2000003. If this is the number, then over here what we can see is there are zeros in between 2 non-zero number. So there will be 1, 2, 3, 4, 5, 6. So in total there are 6 significant figures. This is the second rule. Now the third one. Okay, now the third rule. The third one is all zeros to the right of a non-zero digits having no decimal point are not significant. Suppose if it is done through a calculation, then Suppose if the calculation is done and your answer comes out to be, suppose like this. There are no decimal points, okay? The answer is something like that. So this whole number is a significant number, okay? So there are 6 significant figures over here because this is done through a calculation. And if you miss 1 0, there will be a huge difference over here. So there will be total 6 significant figures because there is no decimal points over here. Now the fourth one. All zeros to the right of a non-zero but on a left of a decimal points are significant. Suppose there is a number like this. Okay? Now over here there are 2 zeros on the left and on the right there are also 2 zeros of a decimal point. So over here not all these zeros are counted as significant figures. Only the zero which is there to the left, okay, to the left are counted as significant figures, not on the right. Okay, the number which is left to this decimal point are counted as significant, and the number zeros which are to the right are not counted as significant figure. Had it been accompanied by another digit over here, suppose it is 5 over here, then this would also be counted as a significant figure. But there is no other non-zero digit. It ends with 0 0. So these 2 0 are not counted as significant figure. Okay, so over here there are 5 significant figures as these 2 will not be counted. This is rule number 4. Now rule number 5. All zeros to the right of a non-zero decimal point are significant. Suppose there is a number like this. I have already given you this example. Suppose the number is 0.5600. Now there are 0 zeros over here, but this is in with the non-zero digit. So over here there will be 1, 2, 3, 4 significant figures. Okay, this is the 4th rule. Now when we do the numericals and so on, you'll be more clear with the significant figures. Okay, it might be a bit confusing right now. Now the 6th one. All initial zeros on the right of decimal point but not on the left of the non-zero digit are not significant. Suppose there is a number like this, 0.345. So over here, this 0 is not a significant figure. Over here, there are only 3 significant figures. Another example for this would be 0.0345. So over here, these 4 numbers will be the significant figures. This 0 will not be a significant figure. Now the last one. Decimal point does not affect the significant figure. Okay, this rule, when we do the calculation, I'll tell you how it is determined. Okay. Now, while doing the measurement, more the significant figures or more the digits, the more accuracy of the calculation will be seen. Okay. If more numbers are there, then that is a more accurate answer. Okay. Now we'll discuss about rules of rounding of a number. There are various rules. I hope this is like quite similar to this we have done before also. But these are the rules you need to remember. Okay, the first rule is rule for rounding of digits. First one is if the digit to be dropped in less than 5, then preceding is unchanged. Suppose if you have a number like this, 3.454. Now whenever you round this kind of a number, rounding of this kind of a number, you see this last digit over here. There is 4. This is less than 5. So if it is less than 5, we can remove this. You can simply write 3.45. This is done rounding, first number. Suppose if this is greater, we just have to see if this is greater or less than 5. Now we have similar number. Over here the last digit is greater than 5. So in this case what we do is we add 1 to this one. So this becomes 2.46. Okay, this is the second rule. Now the third one. Suppose the number is 3.455. Not more than 5, not less than 5, exactly 5. In this case also what we do is we raise it by 1. Which means that if this last digit is less than or 5, then we add 1 to the preceding digit. This is the rule how we round up the number. Now there are a few questions in your book how to add, subtract, multiply significant figures. These are quite important. You can check the question number in your book. I have picked few questions. I will do that. Okay. Now to add the number. The first question is to add the number. Numbers are 3.8 into 10 to the power minus 8 plus 4.2 into 10 to the power minus 6. These are two numbers. We need to add the numbers. Okay, you have to be careful and write the answer in the terms of significant figures. You have to tell how many significants are there, figures are there. Now first of all, what you have to see while adding this sort of numbers is, you have to see how many zeros does that 10 have. It is minus 8 over here it is minus 6. So you have to come in between. You have to make the power of the 10 equal. First of all, you have to make the power of the 10 equal. So first of all, we have to make this power minus 6. Or we can make this minus 8. So what we will do is we will make this minus 6. When we take this minus 6, whenever we have minus over here, okay? Minus means we shift this point towards the left. If it is plus, we shift the point towards the right. Okay, now if it is minus, we shift it towards the left. How many zeros you have to drop out to make it 6? 2 zeros. So you have to shift the point before 2 zeros. So if there is no digit over here, you have to add 0. So this is 0.038 into 10 to the power minus 6. Now other digit is 4.2. So we can directly add. So where is 4.2? 4.2 into 10 to the power minus 6. So this 10 to the power minus 6, it will be 10 to the power minus 6. Now over here 4.2 into 10 to the power to 8. Okay. Okay, wait. Actually it will be confusing for you. I'll just write it like this. So what is common over here in this two one? This one. So we will just add these two numbers. So this becomes 4.238. Now, when we write in the significant figure, we compare it with the question. In the question, how many significant figures are there? It is 3.8. It means 2. Over here, 4.2. 2 significant figures are there in the question. So in the answer also, we will write only 2 significant figures. So in place of 4.238, we are just writing 4.2. So this will be the answer. We have to see what is given in the question and then only we write whatever we get in the answer. 2 significant figures in the question, 2 significant figures in the answer. Similarly, this is addition. Another one what we will do is multiply 2 significant figures. The question, you have to find the product of 185 and 1.52. Okay. When we multiply, what we do is we directly multiply these 2 digits and we see where the point can be placed. When we multiply this, we will get your answer to be 281.2. Okay, this is the thing which we get if you multiply with the help of a calculator or just multiply it. So this is what we get. But this is not a significant figure which we need in the answer. So when we have to write in terms of significant figures, just count the digit. There are 3 significant figures. Over here also 3 significant figures. So your answer will be only 281. This cannot be written because we only need 3 significant figures. Now, there is another similar question, that is, you have to find a side of a square. Okay, side of a square is 1.6 meter. Suppose if you want to find the area, if side is 1.6, your area will be 1.6 into 1.6. So this comes out to be 2.56 meter square. Okay, this is the area, but this is not a significant figure which we need. How many significants are there in the question? Only 2. So your answer will be 2.5. Okay, 2.5. meter square. So this is how we calculate the significant figures. There are a few more questions, subtraction, additions. Please do try all these questions, and if you have any doubt, please do ask. Okay? If you don't ask, then I will not be able to know where you have problem, if you have problem or not. This was for today. Thank you.